Hello, welcome to this new webinar. We will start in a few minutes, but first let's check if the sound is working well. You can use the interface and say if everything is okay, or if you have an issue, let me know. So we will start. First of all, the topic of this webinar is the rollout of an indoor and outdoor location solution on the airport site. The presentation will be made by Mr. Bouyaguet from Resonate MP4 and Mr. Carlotti from ELA Innovation. You can ask questions during the webinar, and then at the end of the session, the speakers will answer your questions. So you can use the interface to ask questions during the session. The agenda of this presentation will be the next one. So we will start with the context of the project. Then we will talk about the architecture of the solution. Then we will do a focus on the tag were used during this project. And then we will conclude with the feedback of this project. So I leave the floor to Mr. Bouyaguet from Resonate.
Hello, good morning. Then I'm Jean-François Bouyaguet. I'm the president of Resonate MP4, and we are the software editors which developed the XOPS solution. Then the context, we are deeply involved in the airport operation and airport software development, and there is a very, very big request now for security and safety on the airside, and there is more and more audit emerging from everywhere to deliver data about the security of the airport. Then the main issue is to secure the non-motorized equipment, because most of them are very frequently abandoned on the airside, and it could bring some danger for the aircraft, especially when we start the reactors. Then we needed to find a solution to locate and to secure the equipment, and making sure that the equipment were correctly parked on the correct territories, to avoid that anything stay on the ground when we were pushing the aircraft, or when we were docking the aircraft to the bridge. It's a very complex organization because it's a very, very large airport, and we have a lot of aircraft and operation joining and leaving the airport. Then, just to give you an idea about the challenge on an international airport like Heathrow in London, CDG in Paris, or Los Angeles, Atlanta, there is always more or less between 10 and 12,000 non-motorized equipment on the ground. And the airports are very, very large. Just to give you an idea, just the lengths are minimum 6 kilometers. It means 4 miles, 4.5 miles. And we have more or less 15,000 people working on the ground who are able to move your non-motorized equipment. For instance, the lollies that you see on the pictures, because they think it's like an obstacle, and if they want, they can move it and they can push it, and sometimes they bring it outside of the airport and nobody knows. Even it looks very basic, it costs more or less $3,000 US. Then it's a real issue. And as we are operating 2,000 flights a day, you could imagine how much these equipment are moving on the ground. The target was for us to secure the site, and to also make sure that nobody steals the equipment. The second was to optimize the equipment fleet, because today the airports are limited. They cannot extend. They are very constrained by the geography. Then they want to increase the number of flights coming in and coming out, but they don't have the surface to park the equipment on the ground. Then you need to find a solution to optimize your fleet and to save space on the airside to be able to increase the capacity of your airport. Then the new usage is the pooling, the sharing of the non-motorized equipment. It means that all the operators on the airport used to buy their own equipment in the past, and now they accepted to invest and to have a community, a cooperative system to share the equipment between them, and they pay the maintenance cost according to the use they've done during the month. With this, we can, of course, reinforce the security, and the return that we got, what we have seen is that we can reduce by 1/4, by 25%, the number of non-motorized equipment on the airside. Our company, the company is called Resonate MP4. It's based in Paris, but most of our people are working overseas. Our biggest station is in UK, in London Heathrow. We have also a strong team in Romania, especially for the software development. We have a branch in Boston because we are doing operation in Boston, and also we have some user like Primair Cargo, which is the airlines of Amazon in US. Then we are equipping their different hubs in US. And we have also a branch in Thailand because it is our head office for South Asia. As I told you, we are dealing and we are working on in US, Canada, in Europe, mainly in France, UK, Spain, and Germany. And we have also some development in India, Singapore. We are very strong also in Hong Kong because we are dealing with all the motorized equipment in Hong Kong, and we started last year to operate also in Vietnam. Our company is labelized in Europe with a special label, which is an innovative company. And we developed software only since 2007, because before we were just focusing on research and development, and we were subcontractors from a company like Thales, Honeywell, which were asking us to develop some special hardware and software. Since 2015, we are fully dedicated for the airport. We are not doing anything else. And our main customer are the airport like Heathrow, Paris CDG, Paris Airport, Hong Kong Airport, or the airlines like Air France, Ryanair, Primair, DHL for the cargo activity, and also some subcontractors of these airlines, which are we call them the handlers. Then we have ONET, WSS, this international group managing airport handling all over the world. Now the architecture, as we were already securing and tracking the motorized equipment where we can catch some power, some energy, because they are mainly electrical equipment now. It means they have the battery system on. Then we could connect our telematic on this kind of vehicles, and we could locate these vehicles through GPS, classical GPS, and we were communicating the locations through the GSM 4G network to a server in the cloud. And on the cloud, we have the maps, and you can display your motorized equipment on the map, and you can see how they work and all the technical data. The idea was for the non-motorized equipment to find a solution to save the energy, because we didn't want to maintain the device. We didn't want to change the battery. Then we were looking for a solution where we could be certain that the system could last at least 10 years without touching the equipment after having installed. Then we selected the PUC ID Bluetooth of ELA, And this Bluetooth is emitting every 4 seconds because we need a very high frequency of emission. Because, you know, as there is a lot of aircraft moving on the airport, we cannot be informed every 10 minutes about the location, because in 10 minutes you could have 2 different aircrafts docking and leaving the parking stand. Then we needed to have a high frequency, and we considered we need information every 4 seconds. Then we have a high frequency of emission, and we wanted also to have a long life cycle for the battery. Then the only solution we have is to secure a Bluetooth detection between our motorized equipment and the non-motorized equipment. Then we can configure it between 5 meters to 50 meters as we want. This can be done over the air on the box. And when the motorized equipment are moving around on the air side, when they are nearby to the non-motorized equipment, they get a connection. And then we identify the number of the puck, and we send through the box the information to the map with the location that we catch from the GPS cells on the motorized equipment. Over the mobile and motorized equipment, that's where you see the box on the right, the corner, bottom corner on the right, we can add some fixed antenna in the place where it's forbidden to go with a mobile equipment. Then, for instance, the hangar where we are doing the maintenance of the aircraft, we just set some fixed antenna, and these fixed antenna are also connectable through Bluetooth network. And when there is some equipment on the ground, like tools or beams or whatever, then this antenna send the information of the location of this equipment in the indoor territory to the server, and then we can extend the location to the indoor and not to be just limited to the outdoor. Also in the middle, more and more you have people working on the ground with some special tablet or PDF for scanning the baggage, scanning the cargo and everything. Then we can install on their tablet or mobile application, and when they are nearby also the equipment, we use their tablets to locate the equipment, and also it's enhance our tracking system, and we deliver also the same data of location on the maps in the cloud application. Just to give you an idea of the size of the puck, it's very small, easy to stick. Then it could be stuck on the dollies where we put the ULDs for the baggage in. Or also we can integrate this on the shocks that you see on the pictures. This is the system to stop the aircraft, block the aircraft, and then we integrate the puck inside the shocks, and then the airport are certain that they have enough shocks on all the parking stand when an aircraft arrives, because if you don't have shocks in front of the wheel, you cannot disembark the passenger. With this, you can display all the equipment on the map, and also you can define with XOPS some special territories, and then the system will automatically do an inventory on real time of the different non-motorized equipment located on the different territories. And also you have some colors, some square with blue, with green, with red. This indicate the last time that someone has used this equipment. When it is green, it means that someone used the equipment in less than 15 minutes. When it is blue, 30 minutes. When it is red, 45 minutes. And up to black, dark black. And when it is black, it means the equipment has not been used for more than 1 day, 24 hours, and then it sent an alert to the maintenance team to have a look on this equipment and to know the reason why nobody used it. Maybe the there is a technical problem, something broke down, I don't know, and then they can retrieve the equipment, repair, and re-inject the equipment on the production. It delivers in the control room some graphs because their interest also is balance your non-motorized equipment between the different territories. For instance, if you are in the, I don't know, LA and Los Angeles, you have the international terminal and you have the domestic, Delta and Southwest terminal. And the equipment are moving from terminal to the other terminal because sometimes you load baggage on the terminal and then you have to unload baggage and to send it back to another terminal and then the equipment are always moving between the different terminals. And to operate the aircraft, you have to be certain that you have enough dollies to operate the different aircrafts coming on the terminal. Then with this, you you set a territory around the terminal, and you know in real time all the non-motorized equipment leaving or entering your terminal. And if you have a nominal line, which is the perfect number of equipment, you see how your fleet is varying around this line. And when you exceed some limits, it gives you an alert to ask the maintenance team to pick up some equipment somewhere where you have an excess to balance the shortage that maybe you have on this terminal. With a single click on the territory, also you can have a pie with the number of equipment in real time in this area. And when you go to the pie and you put your mouse in front, then automatically you have the list of the different type of equipment accounted on this place. When you have an area where you have a very low traffic, then you don't have too many mobile devices coming there to detect your motorized equipment. And maybe you have a risk that an equipment, because of the storm or whatever else, with a big wind, you have some stairs pushed in the grass or far away from the parking stand. Then with this fixed antenna, you have a 24 hours solution to detect any equipment around this place. And also with the picture you see on the screen, you have a double flows calculation. It means also you can have on real time nature and calculation of the non-motorized equipment going from A to B or from B to A in real time. And this could be helpful in case of congestion, because if you have a lot of congestion, it means you have a lot of traffic going on a very limited place. It could delay your aircraft because you will be late to deliver your equipment to the parking stand. Then you have some alerts coming from also this kind of antenna telling you that the flow is too slow now, then there is a traffic congestion, then please go by another way to the terminal, take a new direction to avoid to delay your aircraft.
Thank you, Jean-François. Oh, sorry. Thank you, Jean-François, for this presentation. I am Hugo Carotti, Canada Sales Manager for ELA Innovation, and today we are going to talk about why our tags are adapted to the airport field. So first of all, a bit about ELA Innovation. We are a French tag and sensors designer and manufacturer based in the southeast of France. We've been created in 2000. We started with an active RFID range, then Bluetooth Low Energy, and more recently Bluetooth Mesh and LoRa range. And our DNA is the ultra low power consumption and very long battery lives. We are about 30 members big, 500,000 units deployed, a quick growth over the past few years. Half of our sales are going to the international, and 30% of our revenues are going in R&D, so we are always on the ball regarding new innovations. So now if we focus on the airport application, in our range, the ones we will be focusing on for this use case are the active RFID and the Bluetooth Low Energy ranges. So we provide various casings going from the blue Slim ID, blue Light ID that are 2 millimeters thick and 5 millimeters thick that can be used typically as key fobs for driver identification or for asset identification. The Coin ID, which is about 1 centimeter thick, and the Puck ID, the one we used for this application, which is 2 centimeters thick, and all of them with industrial casing in order to be adapted to harsh environments. So now, if we focus more on the installation into the airport, you can see on the bottom right pictures of the Puck installed into dollies. So first of all, they are sturdy. They are waterproof IP68, and they have a Delrim casing, so they are able to withstand shocks, for example. They have a very high autonomy, so we are talking about 18 years for an advertising period of 10 seconds and 12 years for an advertising period every 4 seconds. They are compact and discreet, with less than 6 centimeters diameter and 2 centimeters thickness. And in order to help you locate your assets on the last meters, we have peak to light features, which is with a LED that can be light on, turned on in order to find your asset. Now about the installation, properly speaking, of our tags. So as you can see on the pictures, for this application we used stickers. So these stickers are also used by car manufacturers in order to stick metal parts together. So it's really a strong sticker here that we are using that allows the Puck to be routed to the asset all along its battery life. They are easy to use because of the BLE communication. So they are compatible with numerous GPS trackers and mobile equipment such as tablets, smartphones, or other objects available on the market that are Bluetooth compatible. They can be parametered with an NFC technology, so with a proximity scan, either with an NFC reader or with a compatible smartphone. And the last point is, in case the trackers used inside the motorized equipment on the airport or on the field are not equipped with Bluetooth, we can switch to active RFID technology using the same tags. The only difference is that we would have a RFID reader connected to the tracker in order to do the interface between our tags and the tracker inside the vehicle. So now I'm leaving Jean-François to talk about the feedback and the next steps regarding this project.
Okay, what we get from this experience, because I forgot to tell you that the initiative came from the airport authority, which were looking for a very safe and secure solution to track and non-motorized equipment on their site. And they set up a community with various operators in Paris. And there were more or less 6 different partners. And they share the cost of the studies to find out the best solution to answer to their needs. Then after 1 year of different testing period with different equipment, we selected the Puck ID Bluetooth, and the feedback of the community after 2 years using this system in CDG, where we have more than 5,000 equipment already on the database, is that it's a good tool because it's perfectly integrated in their maintenance process. Because the people working on the airport, it's like the people working on the harbors they are a bit rude. Then they are not very careful about the equipment, and you need to have very solid and strong technology and very well fixed. Then we didn't have so many puck to replace, maybe a few, less than 10 on 5,000 equipment, and because of a very special occurring. But the interest is, as you have seen, it's easy to stick. It's very solid. You don't have to drill. You don't have to use your equipment. And sometimes we are not able. It's forbidden to bring this kind of equipment on their site. The sticker is perfect. Also, it's very fast. Then you don't have to prepare a budget to install your puck, because with the classical system where you have to dig and use the screwdrivers and everything, then people cannot install more than 4 or 5 equipment per day and per person, maybe 10. With the puck, we can install up to 150 for one person in one day. And it's much easier. The solution is very cost effective. The price is the cheapest if you compare with the other tracker. Then it's easy to install, it's solid, and it is the cheapest one. And also, thanks to this technology, because of the development we have done on the software, we started also to share and to pool the equipment. And with this, we have a perfect tool to report and to build the global maintenance and the global investment in the non-motorized equipment fleet according the usage of the different operators. There is no doubt now, because everyone can have a look on the platform, and they can check every day how they use the equipment compared to the competitors, and they accepted to pay the investment and the running cost during the past 2 years.
Okay, thank you, Jean-François and Hugo. If you have some questions, it's the moment to ask them. So the first question is there any restriction regarding the frequency used at the airports?
That's for me. No, the interest is the Bluetooth. The Bluetooth is open everywhere. It's a free access. And even, you know, that now Airbus and Boeing are developing the Bluetooth to connect between the passengers on board. It means it's also encouraged now by the aircraft suppliers. And no, there is absolutely no risk with the Bluetooth and no interference, because even the people operating for the airport or the airlines, all of them also use a different system connecting by the Bluetooth.
Okay, thank you. So I don't see any question more. I think it will be clear for everyone. So we will close this webinar. Just to remind, the webinar replay will be available on ELA's website. And we will send you an email with the replay link also. So if you have more questions after this session, feel free to ask them by email. You can use the email address in the invitation. So thank you, both of you, for this presentation, and then have a good day.
Bye-bye.